And now we've got the tables. I've spotted the glyph table entry over here, which is pointing us to byte location 35,436. So that's where we're headed next. Let's take a quick look at the manual first though, and it looks like the first bit of information we'll be given is the number of contours that make up the first glyph in the table. Interestingly, that value can be negative, which would indicate that this is a compound glyph made up of other glyphs. But let's worry about that later. We then have a bunch of 16-bit F words, which tell us the bounding box of the glyph, and following that comes the actual data, such as these X and Y coordinates here. I'm eager to get my hands on those, although we should take note that these coordinates are relative to the previous coordinate, so they're more like offsets, I guess we could say. And they can also be in either an 8-bit or 16-bit format, which I assume these flags here are hopefully going to tell us. Then there's also an array of instructions, which I believe is the scary bytecode stuff we're skipping over. And finally, or I guess firstly, I'm not sure why I read this table backwards, we have indices for the endpoints of each contour. So if I'm understanding this correctly, we're going to read in a bunch of offsets from which we can construct the actual points, and then say we get two contour end indices, such as 3 and 6 for example. That just means that the first contour connects points 0, 1, 2, 3, and back to 0, while the second contour connects points 4, 5, 6, and back to 4. That seems easy enough, so the other thing to look at is that 8-bit flag value, although only 6 of the bits are actually used, it seems. So we're going to have one of these flag values for each point, and according to the manual, bits 1 and 2 tell us whether the offsets for that point are stored in an unsigned 1-byte format or a signed 2-byte format. Then, getting just slightly convoluted here, bits 4 and 5 have two different meanings depending on whether the 1-byte or 2-byte representation is being used. In the first case, it tells us whether that byte should be considered positive or negative, and in the second case, that's not necessary since the sign is included in the offset itself, and so it instead tells us whether or not we should skip the offset. That way, if the offset is 0,